So what we're going to do, guys, is we're going to talk about reciprocal trig functions. We have the big three, sine, cosine, tangent, and we have our little three, which are coming up next. We're taking reciprocals. The first one here, we call that cosecant. Cosecant. And cosecant theta is the reciprocal of sine, so it's 1 over sine theta. Secant theta is 1 over cosine theta. And I had this wrong. I had tangent theta there, so I took it out. But cotangent theta is 1 over tangent theta. Here's a really cool thing, guys. To evaluate these functions, you switch them to their more familiar big three version. I personally still don't like to leave them in cosecant, secant, and cotangent form. When I'm evaluating problems, I just revert back to their sine, cosines, and tangents. And that's what we're going to do today. So it's just adding an extra step to the simplifying or evaluating trig expressions by taking the reciprocal along the way. Either you do it first or you do it at the end. It doesn't matter. You don't have to actually do it if you can learn how to deal with it on a triangle the other way. As in, do you know what secant or cosecant or secant or cotangent is? And then boom, you can find it just like SOHCAHTOA. So there's ways to get around it without switching, but I think switching is the easiest way. So, first off, I want you to take A, and I want you to find all 6 trig functions for angle A. You got your sides, so listen. So I would start off with sine of A, cosine A, and tangent. So, as I just heard sine, I think, done wrong, I will now say, if you guys don't remember what they are, write them down, as in, write down your familiar phrase, SOHCAHTOA. I don't have a phrase or a way for the other 3, the little 3, but the big 3, we have this way that we are able to use to help us remember. Okay? So none of us should be having an issue once we write that down with what the ratios are. But sine is opposite over hypotenuse, which according to our XYZ sides is what? Well, you look like you're going to say something.
Y over Z.
It is y over z. Cosine of A is x over z. And tangent of A is it's y over x. We got to find the other 3. We got to find the little 3. The other 3, ladies and gentlemen, are cosecant of A, secant of A, and cotangent of A. They're functions. So now if we're going to be doing cosecant of A, we need to say, hey, wait, cosecant was 1 over, cosecant was related to which one? Sine. So it's 1 over sine, in this case not theta but A, because we're working with A here as our angle. Now, wait a minute, we know what sine of A is. Sine of A was y over z. So therefore, this becomes 1 over y over z. Wait. I don't like dividing by fractions, so therefore I take it and multiply by the reciprocal, or flip it. So the answer here for the cosecant of A is z over y. Because you're dividing by a fraction, we flip and multiply. Same thing with the secant. Secant, though, is 1 over cosine. Cosine of A, we know that. It's x over z, which ends up being z over x. And the last one, cotangent, is 1 over tangent of A, which is 1 over y over x. So which ends up being x over y. Ladies and gentlemen, can you see any kind of pattern that's going on? Each function and its reciprocal function, their answers or their ratios are the reciprocals of each other. So technically this middle stuff was just to get us to the point where we had our ratio. So if you can remember that cosecant is z over y when sine is y over z, then you don't have to do all this changing of things. But most of us will go through that process here every time we do a problem. It's okay. So, how do I use this? What am I going to do? I'm going to evaluate problems. Problems that are going to be not only have to use coterminal angles, not only will I have to use reference angles, I will also have to switch it to the big three. If you take a look at those two problems we have on the board, they're both in little 3 form. So to me, I don't like it. I'm going to switch it to the big three. The first one is secant of 330 degrees plus cotangent of 480 degrees. I'm going to switch. I'm going to find coterminal angles, and I probably will also use reference angles because sometimes it's easier to use those. That means you can use your unit circle. You can use your reference triangles. And again, when I'm dealing with tangent, which cotangent ends up being, it's not on the unit circle directly. You have to find it. Or just use the triangle. So, how do I change secant into the big three? That would become 1 over.
Are we still using the same thing?
What do you mean using the same thing? Secant of 330. What would that be if I wanted to switch it to one of the big three? So 1 over cosine of 330 degrees, yes? Plus 1 over tangent of 480 degrees. All I did was now switch it to a sine, or cosine and tangent, a big three, because we know those. We should know those by heart. We should be able to say, hey, got it. Okay. Now, hey, wait a minute. We can use our unit circle for the 330 degrees, so you take that out. We have 330 on our unit circle. And wait, it's cosine, so we're looking for the x or the y. The x, cosine's x. What does it happen to be? And is it going to be positive or negative? 330 degrees is in the 4th quadrant. X is positive. So it's going to be positive what? Square root of 3 over 2. We're going to have to fix that, obviously, but okay. Plus, I don't know if I like tangent of 480. That's not on my unit circle, is it? First of all, tangent's not. But 480, that's too big. I want to be on the circle, right? So what would I have to do? I'm not gonna add to 480. I'm just going to subtract, and I'm going to subtract what? 360 to find a coterminal angle. So I'm going to subtract 360, and what do I get? Tangent of 120. Second quadrant, yes? Okay. That's one line. Now, starting to clean things up, what can I do on the left-hand side of that? Make it 2 over square root of 3. I fixed it. I like that. The problem here now is that I need to add 1 over the tangent of 120. Wait, I don't know. 120 is in the second quadrant, yes?
Yes.
Maybe it'd be easier because tangent's not... I know where 120 is on my unit circle, but I don't have tangent. I have a cosine comma sine. So maybe for tangent, it might be easier to find a reference angle and then go back to my reference triangle. What would be the reference angle to 120? What's the leftovers, guys? Yeah? What are the leftovers to 120? You can. That's an option. You can do sine divided by cosine. That sets up a fraction with fractions with it. So
Okay.
some of us might get a little scared of that. So I hope everybody recognized that 60 degrees would be the reference angle to 120. So that means I want to do the tangent of 60. But here's the problem. In the second quadrant, tangent is positive or negative?
Negative.
It's negative. All students. So therefore, I should have a negative sign out front. Going through the whole checklist, we've done this before. I could figure out tangent of 60 by making my triangle. 30, 60, 90, 1, 2, square root of 3. What's the tangent of 60? Tangent is opposite over adjacent, which is square root of 3 over 1. Do I really need to put the over 1?
No,
So it stays the same. So it's 2 over square root of 3. Now, does everybody recognize that that negative is still going to be there here? I'm just replacing tangent of 60 with the square root of 3. So can I take this negative and move it up? And so can I write that as minus 1 over square root of 3? Is that going to be okay? I'm trying to make it easier for myself to put things together. The reason is because these two equations, or not two equations, sorry, these two fractions have a what? Common denominator, so therefore I can add or subtract them. What is 2 square root of 3, 2 over square root of 3 minus 1 over square root of 3? It ends up being a 1 over square root of 3. At this point, we would say, hey, I don't like that. And we fix it by doing what? Yeah, multiplying the top and bottom by square root of 3. So I get a square root of 3 over 3. Boom, done. Now, we just talked about on the last quiz, we got introduced to what were radians, right? So now, not only can I throw it at you with degrees, I can mix it up and put radians. Heck, I can do one of each, or 10 of each in the same problem, put it all together. That's 2/3 cosecant of a negative 3 pi over 4 minus the secant of 11 pi over 4. It's in radians, and they're both not on the original circle between 0 and 2 pi. So in this case, I will have to find coterminal angles for both of them. But I'm not adding or subtracting 360. I will add or subtract what? What am I going to add or subtract in radians for coterminal angles. Not 180, we're in radians.
Oh, is that
2 pi. But here's the thing, guys. We talked about adding 2 pi or subtracting 2 pi. When we're in radians, most likely we have fractions, and so you have to have a common denominator. So therefore, we have to kind of multiply top and bottoms. I want it to have a 4, so 2 pi really looks like what in fourths? How many fourths do you get when you have 2 pi? Multiplying top and bottom by 4, or 2 times 4 is? 8. So you get 8 pi over 4. So that means I probably want to add 8 pi over 4 here, right? This one, I'll subtract 8 pi over 4. Why am I writing it this time, but last time I didn't? I mean, you don't have to. But why is this? Why would I write this one down, but on 360 I didn't have to do that? I think 360 is just a little easier to work with. You didn't have to worry about the common denominators. You just take 480, subtract 360, you got 120. On these ones, guys, it's a negative 3 pi over 4 plus 8 pi over 4. What are you left with? I'm left with 5 pi over 4 minus secant of what? 11 pi over 4 minus 8 pi over 4. You're left with 3 pi over 4. Hey, wait a minute. Is 5 pi over 4 and 3 pi over 4 on the unit circle? Yes. And it's in cosecant and secant. Oh, I don't like that. So let's switch it out. Cosecant turns into what? 1 over sine of 5 pi over 4 minus, I don't want secant, I want 1 over, secant is 1 over cosine of 3 pi over 4. Wait a minute, I can go to 5 pi over 4, which is in the third quadrant, at 225 degrees if you had to. And what's the sine value? First of all, third quadrant, sine and cosine are both negative. So what do you end up having? 2/3 times negative square root of 2 over 2. Yeah? Minus 1 over, what's the cosine at 3 pi over 4? Using your unit circle, people. What do you have? It's a negative square root of 2 over 2. It's 135 degrees. It's a 45. All 45-degree angles have for sine and cosine square root of 2 over 2's. Hey, a negative subtracting a negative makes a positive. Let's get rid of that. On the left one, what happens to the 2's? They cancel each other, don't they? Okay, moving over. That means I'll have a negative square root of 2 over 3 plus, I don't want that fraction there anymore. So what do I do? What's that? Makes it 2 over square root of 2. This is different than I got from last hour.
You probably did it wrong last hour, or you're doing it wrong right now. It's got to be 1 to 2.
Why is it 1? Why is it
That's why. That's why. This is not right. Here.
Yeah,
That wasn't right. It's 2/3. It's 1 over negative square root of 2 over 2. Okay, guys. Did you guys everybody see my mistake? It was 1 over the negative square root of 2 over 2. So I have to flip that one as well. So it's 2/3 times 2 over square root of 2, and that's negative. Yes?
No. Wait. What are you switching?
I flipped the fraction here.
Which one?
That one. So the 2 gets to go to the top, negative square root of 2 stays in the bottom. Gentlemen, be quiet. And yes, that was recorded. Plus, I flip that one, and that's 2 over the square root of 2. Correct? 2 times 2 is 4. Can I bring the negative to the top? Just get it out of there. So this would be a negative 4 over 3 square root 2 plus 2 over square root 2. Some of us probably should want to fix that right now. They're freaking out. They're saying, I got square roots in the bottom. What if I said, I don't want to fix it right now. I just want to put them together. Yes, I have to take the second fraction and multiply it by 3 over 3. That'll allow me to have a 3 square root 2 on the bottom as well. Common denominators. So, change colors here so you can see that. Oops. 3 and 3. So I get negative 4 over 3 square root 2 plus 6 over 3 square root 2. And so what does that leave me with? Negative 4 plus 6 of them. 2 over 3 square root 2. Now I'm going to fix it by multiplying the top and bottom by square root of 2. So 2 square root 2 over 3 times 2. Because square root 2 times square root 2 is 2.
Yes.
I left it like this instead of a 6 because what happens to the 2's? They cancel. And so your answer is square root of 2 over 3. We're going to talk about permutations again. And I'm actually going to give you something called permutation notation, which has a button on your calculator. How many permutations are there of 22 things taken 6 at a time? So, 1, 2, 3, 4, 5, 6. How many you get to choose the first time? How many you get to choose? How many things are there the first time you go and grab? How many things are there? There's 22 things. You're taking 6 of them. So the first one is 22 of them. The second time you reach into the bag, how many are there?
0. If you're taking all 22 of them.
And I'm not taking all 23. I'm 22. There's 21 of them, right?
What are you talking about?
There are 22 things in the bag, guys. I'm only taking 6 of them.
Taking 6 at a time?
Yeah,
I'm only taking...
16.
Okay. When we say this, guys,
Then you take out one.
we're taking 1 at a time, but we're only taking 6 of them.
Total of 6.
Total of 6 of them.
So now it's 6 at a time.
Right. This is the way they word it in the book, guys. Yes, I can see where that's confusing. You're not grabbing 6, so it's not 16, okay, for the next group. You're taking, there's 22 things, and you're ordering 6 up total. Taking 1 at a time, but you're only allowed to take 6 of them. So the next one would be 20, 19, 18, 17, and then we went back and we multiplied all those, right? So if you take your calculator out, what do you get? You should be able to get 53,721,360 permutations of that, okay? It gets large really quickly. Well, here's the thing. I don't know how many people want to sit there and actually do 22 times 21 times 20 times 19. We had to do that on one of our quizzes, right? What if I said there was a slightly easier way? Now, what happens, guys, is you don't have to necessarily remember this first part, is that you start off with n things, and you're taking r of them at a certain time. So you got n, then it's n minus 1, n minus 2, n minus 3, 4, 5, 6, 7. And what happens is it gets to a point where you're taking the r thing. I don't know if you're going to say arth thing. So we're taking the arth thing, and that thing, when we're dealing with it in a sequence, is not n minus r. It's always one more than that r value. Or one less, I guess you can say. Why is that? Let's go back to our other problem here. And say, well, that starts off as n minus 1, n minus 2, n minus 3, n minus 4, and n minus 5. It's always one less than your number, as in going downwise, because your first term has to be stated as n, your starting point. Then you start your numbering. That's why here we have it as n minus r plus 1. I'm not too hung up on that. I don't care about that too much. What I do want you to understand is this thing. Whoops. This thing. This is called permutation notation, where you have n, number of things you have, taken r at a time. So you're only grouping, you're taking 6 of them or 5 of them. How does it work, guys? It works as in, here it is, n factorial over n minus r factorial. So wait a minute. Let's go back to our problem we just talked about. Wasn't that 22 things taken 6 at a time? So, what would that look like? Well, here's the thing, guys. There is a button on your calculator. I'm not necessarily showing you where it is. For some of us, it's right on the keyboard, on the front face, under the second menu. Some of us, it's under PBR, I think, problem or something. It's going to have an N, a P, and an R on it. It's in a different menu for some calculators. Okay, now, what does it look like, and what do I want to see? I want to see this, whether the calculator is used or not. I want to see that it's 22 factorial over 22 minus 6 factorial, which leads us to 22 factorial over what? 16 factorial. Now you can use your calculator. At this point, that's where your calculator comes into play, and you'll end up with the 53,700,000. Now, to use this, you have to put in 22, hit that notation button, and then put 6 and then hit enter. I am not showing you necessarily because I don't think you need it. Exclamation point is factorial.
Holy crap, I just got it.
Okay, now, this works because 22 factorial, guys, over 16 factorial. Isn't that 22 times 21 times 20 times 19 times 18 times 17 times 16 factorial? All over 16 factorial. We did this before. And what did we do with the 16 factorials? We canceled them. And isn't this the same number that we had in originally? So that's why it works. Last 3 problems. Tell me the answer, or set it up, and then give me an answer. So, 12 things, guys, 12 things taken 4 at a time. So, what would it look like in notation?
12.
Okay, over. Yeah. Make sure you put parentheses around the 12 minus 4, which leads us to 12 factorial over 8 factorial. And now use your calculator, and you end up with what? This is where I would just use this notation. Instead of trying to put it on my calculator, just put 12 factorial divided by 8 factorial. Boom, your answer is 11880, 11,880. Are we able to get that?
Yes.
Mr. Konchak, this one will be 6 factorial over 6 minus 6 factorial. Wait a minute, Mr. Konchak, that's 6 factorial over 0 factorial. I can't divide by 0.
Oh my god.
What's 0 factorial, guys? No. It's 1. So it just ends up being 6 factorial, which is, whoops. Which is what? 720. Guys, 0 factorial is 1. Wait a minute. If I have 6 things taken 6 at a time, that means I'm taking all of them, right? So it's just 6 factorial. And obviously 21 factorial over 21 minus 3 factorial, which is 21 factorial over 18 factorial, which is still a fairly large number. What do you get? What do you get?
I don't know.
7,980, 7,980. That's your answer, guys. Homework is worksheet 41. Have a great day.